Okay, so this meeting is again recorded. So everything what you see on my the stream on my camera stream will be actually recorded. So nothing from the chat or from the Zoom. Otherwise, the today we have two topics. Morning we have the session 9, which is about things and connections, and on afternoon Juho will tell you about sensors, actuators, and microcontrollers. And now we are actually switching into Cisco systems, the material. The although the, we are using these Cisco system slides, as they actually are also learning material for the Cisco the what is it, Cisco Community Network Academy, I think it's called CCNA. This is actually the part of CCNA, although we are not forcing you to take any of the Cisco exams. Those are totally up to you. However, on the IoT part, meaning the networking part, it might be a good idea to take those, since later on the teaching probably it will be based mostly on the Cisco systems material, what they have there. But anyways, we are doing this a little bit differently. So actually we start by showing this the material, what they have there. And then basically on the assignment side, let's see, assignments, we have assignment 9. There's supposed to be also assignment 10 there. It will be there for the afternoon. But anyways, for the assignment side, we actually took a look at the Cisco systems, what they provide as the exercises, and noticed that, okay, that's not necessarily what we are expecting from a University of Applied Sciences. By saying that, I need to actually explain something. So this course, let me start presenting this Cisco CCNA course beginning. So practically the target audience for this material is for anyone above teenage or something like that. So it's very general stuff. I'm not saying it's bad stuff or too simple, but it starts from the very foundations. You are already second year engineering students on specializing ICT. So some of that stuff on the exercises would have been just, a little bit too straightforward. So basically, I would guess that it wouldn't challenge you enough, or actually at all. But anyways, this material what is here, it's really nicely done. There has been lots of experts writing this material, so let's enjoy it. I'll try to make my best to show you the what is really important for you on this material. But anyways, we are not using directly those Cisco exercises unless, well, they fit the purpose. From the beginning, for example, that today's morning exercise, exercise number 9, that's about the making your own circuit diagram and printed circuit board, which is actually one small part of also on the Cisco training. We just uplifted into Metropolia level. Okay, good. So let's take a look at what kind of things we have here. So basically, this now, the first half of the course were more about from bottom up. Last time we had the semiconductors, started from physics, very plain physics. But anyways, physics, and from there, p-n junction, how that one works, fast explanation how it works, and then to the diodes and transistors, which then were applied on this Arduino simulator environment in Tinkercad. Okay, now we are taking a little bit different approach with the Cisco. It's more like top down, explaining the wide picture first and then connections and that kind of stuff. But it's actually pretty good. At least visually good. Okay. Okay, instructor materials, planning guide. Let me skip that one. Yeah. Planning guide. No. Okay, I need to skip this. This is basically the Cisco advice for the teacher. So this material what we have there, you could actually take a look at it. It also have this material which is intended only for the teacher. But well, it doesn't hurt you to also to see how Cisco see things. Okay, what are the things? So this starts basically from the very beginning. So you already have heard some of that one on, especially on the first week. So we are talking about what are the things and then what are the connections. So the course code is IoT connecting things. So basically this one explains those in general. What are the things? Quite evident, we are surrounded by all sorts of intellectual machines around us. We are carrying mobile phones. We are also carrying these smart watches, all sorts of things, even refrigerators, that kind of things are all around us. In addition to that, well, those are usually made to improve quality of life, or well, that's quite hard statement. I would say ease it up a little bit. So buy gadgets to make your life easier. I don't know if it actually improved quality of life. But then IoT helps industry to become more efficient, meaning, for example, now we are talking about IoT factories, connected factories. Especially, I have been visiting the Opel city in Germany, and that's actually already 10 years ago started being an IoT city in sense that basically the Opel manufacturing plant used the just in time the deliveries. Everything came from these subcontractors, so most of the stuff, the truck backs off on the loading dock, and these racks of components are going directly into cars. So the assembly line was done so that there were absolutely no warehouse of parts, but everything came just in time there to make that car. Okay, which means huge logistic operation and also lots of IoT stuff to keep track of everything. Then there's a statement about Cisco IoT solutions. Okay, Cisco system is one of the largest manufacturer of networking hardware and software. And well, that's what they are claiming to have their network connectivity for computing and that kind of stuff. But it's mostly about hardware and, well, some of this now also software is part of the hardware. Okay, Cisco, that's one of the players on IoT world. Building blocks. This is actually pretty good picture. So it's a picture of the temperature control of a room. So basically, there is a user wants the temperature set to 21 Celsius centigrade. Then there is the thermostat, which actually does the controlling. Thermostat has a sensor, temperature, and well, humidity may be there too, but it may have several sensors connected so that it gets information from the sensors and then basically just compares are we lower or higher, and then it has actuator for heating or cooler system. Actuator in the simplest form is just a switch that turns off a heater or so. And then the magically temperature of the room will settle somewhere. So we have sensors and we have actuators, and then we have this controller. So yeah, so sensors, actuators, controllers. Then there's that IoT process flow. Some devices can have more than one function. Yes, you already know that. And look at what the small controllers, they actually, even the Cisco is showing off here. See, it's Raspberry Pi there, the higher one, and the middle one, Arduino Uno. Okay, so yeah, they selected the same things that we did. Although, well, Raspberry actually is widely used in anywhere in the world. Some words about the processes. So those were the gadgets. So we have sensors, actuators, controllers. Then we also have the processes. So we have basically feedback systems. So just like some of our the exercises, the last week exercise was about to try to keep the average the average current flow constant regardless of the voltage and the what kind of load it has. And it just had that one shunt resistor to measure the peak current, and then that low pass filter, RCL low pass filter, to get the low pass filter data to the Arduino. So there is a feedback, and then control system is the one which is controlling the whole thing. And here's a simple picture of the controller systems or system control. Generally, they look like that. So there's a reference, meaning that the value that the user sets, which is compared to feedback. So there's a measured output going into that summing junction there as a minus. So basically, this summing junction on the left is measuring how far off we are from the set value. And this message is, or signal is called error. That goes to the controller. So this is the controller part, the thermostat, which gives the control command to that heat and air conditioning unit, HVAC unit, which is called plant. So in the control logic, so there's the difference or error signal is fed to the controller, which sends signal to plant, and then the feedback has a feedback loop. There is a feedback, meaning some sort of sensor that senses and gives the something which can be compared to the reference number. Okay, closed loop controllers, which you will be actually using these different kind of control loops later on the studies, no doubt about it. So practically there are three kind of controllers, closed loop controllers. Open loop controllers mean don't use them. Okay, it means that you just turn something on and wish that it will settle on the value that you want. Maybe light is something that is open loop. You just turn it on. You don't control how bright it is, but you just turn it on. But if you want to then control the brightness of light bulb, then you need at least a proportional controller, which is basically based on the difference between the measured output and desired input. Yeah, so very simple. You just, if you are far away from the reference value, you will drive your output higher. Not by single steps, but with this error signal. You just multiply that error signal. So you more far you are off, the bigger change you try to make. Integral controller, actually that acronym there, PI, it's actually proportional integral controller. So it has the proportional part, but also integral controller uses the historical data, meaning if you are just approaching slowly to the set value, the integral of that offset is growing, and then if you use that in addition to proportional, then basically you reach this set point faster. Since if you are staying long, just a little bit of the set value, then the integral rises. It increases, and using that data actually, it gives some gain when you are very close to the set value. Then this third one with this PID controller, you may have heard it. It's proportional, integral, and derivative controller. It also includes some the data about how quickly the system is approaching the desired output, meaning that if this integral part is shooting too fast, they will be overshoot. So this the derivative part will try to compensate that overshoot. So PID, when you turn it correctly, it's the fastest way to get into the set value, desired output value, so that the system remains very stable, doesn't oscillate around that set value, but stays there. Okay, so PID is the most used controller type in the world. And yes, Arduino, Raspberry Pi, yes, they can be used to implement PID controllers, no doubt about it. Then there's interdependent systems, which basically brings us back to the real life. So most of the real life systems have interdependent the behavior. So practically one system changes another, and that one changes something else, and maybe even back as a feedback. This global climate change is one good example of that. And now I'm not making a political statement here, but this is just a physics. So if the global temperature rises, Arctic sea starts melting, and we know that already. That's measured, and basically, as reflective ice disappears, darker oceans absorb more heat. So it doesn't get reflected back to the space. And again, temperature rises. On the other hand, this one doesn't show the other part. When the temperature rises, the humidity of the upper atmosphere will be also rising. We will have more clouds that reflect the sunlight. Okay, which actually cools down temperature. But okay, I'm not sure if warming up the polar caps on summer and cooling off the say this more southern part or the equatorial part would make any good things to the weather or climate overall. I'm not sure. I'm not sure. But anyways, so yeah, it was a little bit politically colored opinion or facts. Okay, so processes. So what are the things? Things are the things that we can measure and control somehow. Okay, and what are the connections? So what kind of connections we can make between these things or things and a computer or things and your mobile phone, things and people, things and systems. There are several different models of communication, although okay, only a couple of those are in real use. So this 7-layer representation of communication stack is quite the often used. It's the same as OSI model if you have heard it. So at the lowest level, there's a physical, meaning wire, data link, meaning what kind of data is actually on that physical layer. Network is how these communication protocols go on using those data links and which are used in the physical. Then there's a transport, meaning okay, how can we actually transport data from point A to point B, which is actually based on the lower levels. And then we have the session, meaning okay, you open your browser, for example, get a web page, then it actually opens up a session for your data flow. Then there's a presentation layer, which is in between of your web browser and the session. So presentation is actually in web, it would be the HTML code, how it's actually flowing there between session and application. Application is your browser, for example, like that. Everything is on the top of each other's, and then there are basically 6 interfaces. So practically this application cannot directly go to data link, or session cannot directly go to the network layer, but there are these the interfaces in between, which are called drivers. Different level the drivers. Okay, standardization. The this is the biggest challenge right now. The standardization is quite wild since every single big manufacturer wants you to buy their stuff. So there are actually some things that are standardized pretty well. For example, mobile phones, most of them use the Android from Google. Some of them use iOS, okay, but even those will they understand pretty well each other's, okay, that kind of things. But IoT is now uh, actually going into all sorts of appliances, and the question is there, how do you connect those? So they are these standardization organizations that try to keep some sort of coherence between these machines and things. But well, we'll see. You will be probably working on, if you're working on IoT, you will be working on the standardization of or proving standardization of some machines or something like that. Okay, models, more models. So TSP and OSI model both actually, okay. Um, I'm not sure if this is giving you too much of, well, enough of information. Yep, you have heard OSI model or TCP/IP model. TCP/IP basically is the how the internet works. OSI model is more kind of more general level. It doesn't actually give you any these protocols or something like that. It just defines these different layers. And then this IoT World Forum reference model too. Okay, simplified IoT architecture is based on, again, basically on the history. So it's more or less like we have a device layer, which is the things that we have had around us as long as we have had microprocessors, or even longer than that. So basically, this is the device itself. But basically, the model actually just gives you that in addition to device layer, you have network layer. So device works as it worked 50 years ago. Now you just add a network into it. So that's the in general the stuff. And then connection levels, practically those 4 connection levels, or actually there are more than that, but those are most common. So one level is device to device, meaning you have one device which is kind of asking on from the other devices some, like if you have a distributed weather sensor system, you have one main unit that checks the reading from the wind, the measuring device, and then with this anemometer, yes, anemometer, and then temperature meter, which is on a shady place, and that kind of stuff. That will be device to device. Then if that main unit talks or sends data to cloud, then yeah, that's a device to cloud, meaning you have the either wireless or the wireless LAN or a mobile phone connection, mobile data connection in your device, and it directly sends stuff to cloud. There are several service providers that actually make products for that kind of connectivity. Another one, which is actually a device to gateway to cloud, meaning you have a separate gateway controller to basically interact with the cloud. And then the fourth one, device to gateway to cloud to application, meaning you may even have this application could be on your mobile phone and it just goes and reads the cloud data, or the cloud sends the data directly to your phone without asking. Okay, but well, this is kind of the game we are playing. Layers. Still layers connecting within networks, and then we have these physical connections, and then we have wire meshes like that. So it only has 6 LEDs here, lots of wires. That looks like Arduino Uno here. No, it's actually Raspberry. I think it's Raspberry Pi. That looks like Raspberry here. And lots of I/O connections from here to there. More LEDs here. So yeah, physical connections, wires, on connections within networks. So the level 1 and level 2, or 3 and 4. Okay, data link. In order to send or get any data to or from internet to your device, actually, it requires some sort of data link and network connections. And there, everything, everything what you need is already invented. You don't need to invent anymore anything yourself here. You just apply those. There are plenty of standards. Okay, now we have that plenty of standards. But anyways, uh, the nowadays most popular data link connection used in wired networks is Ethernet. Yeah, and okay, just 10 years ago, they were still the copper phone lines. That was what in few last years the coppers have been basically cut off because you don't get enough of bandwidth with those, and those are also quite expensive to maintain for the service providers. So most of things are going into the wired networks are going to Ethernet, and most of the data communication is going wireless. Okay, and speaking about wireless, IEEE 802.11, is it E or F or G or something like version right now going on Wi-Fi, and then there's that IEEE 802.15, which is Bluetooth. Then there's of course cellular 3G, 4G, 5G networks. Okay. Then in addition to those, there are some emerging technologies. Let's see what happens to them. There's a LoRa wide area network. So basically that's a long wave radio a protocol which has long distance. I think it's up to 10 kilometers or so. This is fairly long distances, low data rates, very low power. So, for example, they are in the Gulf of Finland. There's a problem with the buoys. Buoys are basically the markers that are marking marking the rocks and stuff, nasty stuff that the boats that actually can run into. Um, so basically, the problem is that those are made of they're basically floaters, and they is a big weight down there. But every spring they start moving because of the ice sheets. They get stuck on the ice sheet, and it can easily carry that buoy 100 meters away or something like that, which doesn't sound too good for a boater. So rock is here and the buoy is 100 meters that way. Um, Actually, some of them, I think it's currently most of those which are in danger of moving are equipped with LoRa, the device which has this GPS there. So it just sends the location of that buoy every uh, day or so, so once a day or something like that. So practically, you just need to have very simple program on the other end on this cloud and just check that, okay, now it has moved a little bit too far from that rock. Let's send the maintenance people to move it back where it's supposed to be. Okay, so yeah, new emerging technologies there. Um, Application connections. So IoT actually, well, it supports as many types of connections as you do, as you implement. So practically all of this is software that runs on a computer. And even a small computer like Raspberry Pi can do lots of different kind of things. You can actually run Python on Raspberry Pi, which is not bad idea at all. So it's a fully grown computer. Okay. More stuff. What is metadata? You may have actually heard a better the definition of metadata. But metadata is actually data about data, or a package of information that tells what the data is. So that's metadata. Everything is now metadata. Um, so basically you can encapsulate metadata inside of XML code. Yeah, that's where I actually heard it first time, when XML was new. Okay, but of course, when we are talking about IoT connectivity, we need to also talk about safety and security and privacy, especially. Um, Privacy, you really need to take into account the possibility that these small systems are hacked. What kind of data you really want to save there? Do you want to actually those have the access, for example, into your Google account? Probably not. You want them to have their own kind of security settings and save as little as possible to the device itself. But those are actually they are separate courses for the securities and privacies and that kind of stuff. But just to remind you, okay, before you get too enthusiastic about building your own devices, you need to also take care of the safety and security. Okay, um, what we heard, IoT is all around us, sensors, actuators, and then the controller, microcontroller, which has software to execute whatever is needed. There's some processes, which is actually steps or actions taken to achieve the desired result. So that's actually kind of the framework of the controlling program. There are layered networking models, and basically they say how devices communicate. And there are several different kind of protocols you can use, or different standards you can use there. But anyways, make sure that it fits the purpose. There's no need to put a wireless LAN, for example, on a small device that sends, say, the temperature reading of room in once a minute. That'll be a waste of the bandwidth. Unless it's just there for the convenient type of convenient way of doing the data transfer. Okay, then last but not the least, maybe the most important thing to remember is the security and privacy the issues, and safety. It basically safety, security, and privacy. Safety is for everything works with the electricity, so it's electricity safety. And then if it has mechanical parts, okay, then it's physical safety and that kind of stuff. Then security, your data must be secure. And privacy means that it would be nice that if your device wouldn't be hacked and somebody would be watching you. Well, yeah, that's pretty dangerous things actually, since now quite a lot of these small the home systems have cameras or microphones on them. It's just waiting for somebody to hack them really good. Okay, yeah, and there's the final slide. Cisco Networking Academy, mind wide open. Okay, so that was the Cisco slideshow. And do you have any questions about this? This was more about the, say, kind of introduction to whatever Cisco thinks is IoT. But it's a starting lecture. You have to start from somewhere. Any questions? No questions, so I will stop recording, and we will have, say, 5-minute break or so.